This presentation discusses a mathematical problem addressing how can I lower my environmental footprint. This presentation can be used to further extend children's mathematical knowledge by relating it to environmental sustainability, a topic they're familiar with and learn about at school. Some of these mathematical problems can be worked out using pen and paper. However, for the calculations involving decimals, students can use a calculator. Understanding the problem. So how can I lower my environmental footprint? What are some of the ways we can lower our footprint? We can look at water and energy to help, but let's look more closely at electricity, which is something we all use every day. Electricity is powered by coal, and this causes pollution in our environment. Coal is a non-renewable resource that we're using up and polluting our environment with. So can we find a better and more efficient solution to our energy needs? So what are solar panels? Solar panels are made from special materials that capture energy from the sun, which turn it into power for your home. They're usually mounted on the side of the roof because that has the most sun exposure, so typically north or west facing roof. And the amount of power produced from solar panels depends on how much sunlight falls on the solar panels. So if you get a large amount of sun like we do in WA, having solar panels would be ideal, as it can potentially save you money and lower your environmental footprint. So some benefits of solar panels: they're a renewable energy resource, good for the environment and help decrease our environmental footprint. They use a renewable energy like solar, so you only pay for what you use, which means you're going to save more. And we get an abundance of sun in Australia. It's free, so why not use it? So making a plan. We're going to explore how we can lower our environmental footprint using solar panels and what the costs involved. We need to find out how much does electricity cost for an average size household each year, and what the cost of solar panels are, and what the savings are for the future. So in carrying out the plan, electricity is measured by the amount of kilowatts used per hour and is based on the power and energy used for 1 hour, every 1 hour. So when mum and dad get their electricity bill in the mail, the amount that needs to be paid is based upon the kilowatts per hour that's used. We want to work out what the benefits of having solar panels would be, so we need to find out how much electricity the average household uses. As you can see in this picture, we're going to focus on the annual consumption, which is 20 kilowatts per day, or it's averaged out to 7289 per year. So we also want to look at the average household, including mum, dad and 2 kids, so we can work out some more from that. So looking at this graph, we are only going to focus on Perth. So it shows the solar energy created when using different sizes of solar systems. So the previous picture told us that the average daily consumption is 20 kilowatts. So what size panel do you think would best suit an average home in Perth? So we'd be looking at a 4 kilowatt system because that produces 17.6 kilowatts of solar energy. And now we need to work out the costs involved. So you can see on this picture here that estimated prices for a 4 kilowatt system are between $6,000 and $9,500. So we're going to say for this exercise, we're going to average it out and do a 4 kilowatt panel system for $6,500. If the installation costs $1,500, we want to add these two together to get the total cost of what the system would be. So this can be worked out by writing it down using your pen and paper. So the total cost would be $8,000. So approximately how much does electricity cost in a year? So we know the average household uses 7289 kilowatts per year, and Synergy, who supplies electricity to homes in Perth, they charge 25 cents per kilowatt. So we're going to need to put those two together to work out what it costs. So firstly, you need the students to write down 25 cents in dollars, so that's 0.25. Now we need to work out what the average household costs. So we need to multiply the total yearly kilowatts, which is 7289, multiplied by the cost of kilowatts, which is 25 cents. So the answer is $1,822.25. So as this was a difficult computation to do by hand, it's best for the students to use a calculator to find the answer. So how much electricity can we generate from our solar system? So remember, our solar system generates 17.6 kilowatts per hour. So how much electricity can we generate from our solar system? So 17.6 kilowatts is what our solar system generates. So we want to multiply that by 365, which is the amount of days per year. So as this is, again, a difficult computation to do by hand, it's best for the students to use a calculator to find the answer. So the answer is 6424 kilowatts per year, which is how much our system can generate in 1 year. So we have now created 6424 kilowatts of clean energy, which has helped lower our environmental footprint. So how much does our electricity now cost for a year? So an average house pays for 7289 kilowatts per year, but our system makes 6424 kilowatts per year of clean power. So how much electricity do we have to pay for? So this can be worked out without using a calculator, so pen and paper. So we need to write down 7289 and subtract 6424 from that number. So that gives us 865 kilowatts that we would need to pay for to cover the rest of the electricity. So how much does our electricity now cost for a year? So 865 kilowatts is what we need to pay for per year. Each kilowatt costs 25 cents, so we need to multiply those two together. So this again is a difficult computation for students to do by hand as it involves decimals, so best to use a calculator. So 865 multiplied by 0.25 gives us a total of $216.25. So we pay around $216 per year for electricity. So how much do we save each year? We can now work out what our total savings each year are with solar panels compared to electricity using coal. So 1822 is what we would normally pay for electricity. We now know that we pay only $216. So we need to subtract these numbers. So 1822 and subtract 216 from that number. That will give us the amount of what we are saving. So $1,606 savings per year. So these savings mean that for an $8,000 system, it will pay itself off in 5 years. So Australia is a great place to have solar panels. We have an abundance of sun, and we should all be utilising a natural renewable resource to help lower our carbon footprint.